All right, we are going to get started with our ionic compounds unit. So we're going to basically go over the basics of ionic bonding, what elements are involved, what an ionic compound is, and then we'll also talk a little bit about ions and the formation of positive and negative ions, which will tie right back into ionic bonding. All right, so chemical bonds occur due to forces of attraction between the protons in the nucleus of one atom and the electrons of another atom. When atoms or ions bond, they're going to achieve a stable electron configuration, which we've talked about before. So, atoms, ions are more stable when they acquire a noble gas configuration. And just remember, noble gases are those group 18 elements. So, neon, argon, krypton. The noble gases have complete octets due to them having 8 valence electrons. And 8 is going to be really important in a little bit. With the exception of helium, which has 2 valence electrons. So, hydrogen can achieve a stable electron configuration by matching up with helium's configuration of 2. So let's get into ionic bonds, which you saw a little bit in the gizmo activity. Ionic bonds are formed by the transfer of electrons, and that's basically the definition that you have to know about with ionic bonds. So there is something that is losing electrons and something that is going to gain those electrons. Only our valence electrons participate in bonding, so just the outer shell. And we're going to first just focus on ionic bonds that can be formed between metals and nonmetals. So in this case, we have our metal, sodium has 1 valence electron, and then I have chlorine that has 7. So I have 1 valence electron, and then over here I have 7 valence electrons. Okay, what's going to happen is those metals are going to lose all of their valence electrons. So for sodium, it's going to lose this 1 electron, and it's going to transfer it over to the nonmetal, which is then going to gain that electron to get a total of 8. So again, this is a complete transfer of the electron. And then what happens is we'll see that sodium has now lost that valence electron. So it will have a full inner shell. Okay, and then when chlorine gains that valence electron, it's now going to have 8 valence electrons in the valence shell. Okay, one other little thing. So one big thing is going to be knowing that metals are going to lose their valence electrons to get that octet, and nonmetals are going to gain valence electrons to get the octet with the 8. One other thing is just some terminology that we have. So when metals lose their valence electrons, okay, they now have less electrons than their protons, so they will become a positive ion. One term that you'll see to refer to a positive ion is called a cation. So you can be like positive about your cats, or positive ions or cat ions is one way to remember that one. Nonmetals that will gain those negative electrons will now become negatively charged, so they'll form a negative ion. And we refer to negative ions as anions. So I think of when I see the word anion, I think of the word onions, and onions kind of make you cry. So you'd be like, most people have a negative feeling about cutting up onions. So this idea of anions are your negative ions. All right, so that's just one big thing. Now, what actually causes the ionic bond is going to be that our positive ion is going to attract our negative ion, because opposites attract. So that sodium ion, which is positive, is now going to be attracted to the negative ion. And that attraction is the ionic bond. Okay, so a lot of information, that one little section talking about metals and nonmetals, metal losing their valence electrons to become a positive ion, nonmetals gaining valence electrons to become a negative ion, and then that attraction that's then going to occur between the positive and the negative ion. All right, a little piece here on just properties of ionic compounds. So compounds that are made up of ionic bonds that you need to know. Ionic compounds, which are made up of ionic bonds, exist as a crystal lattice, not as actual single molecules. The positive and negative ions arrange themselves into a distinct pattern, like you can see over this pattern here. Ionic compounds also are going to usually be existing as solids. at normal, like room temperature conditions with high melting and boiling points. And that has to do with those strong ionic bonds that are going to have to be overcome in order to melt or boil. So, ionic compounds you're usually going to find in the solid state. One other last thing is with conductivity. So, ionic compounds actually cannot conduct as a solid. In order to conduct, you need a charged particle and they have to be able to move. So, because they can't conduct as a solid because the ions are locked in a crystal lattice, which is that first bullet point. So they can't carry a charge through it. However, once they are melted down into a liquid or they're dissolved, now those charged ions can move, so it can conduct. We will come back to, you need to be aware of these properties and be able to identify them as representing an ionic compound. And we'll also come back to these later on when we talk about other types of bonds. All right. The other little part that we're going to go over is just how do we form these ions and what happens to the size of the ions once they've gained or lost electrons. So when ions are formed in the process of ionic bond being made, the size of the ion is going to differ from its original atomic radius. So the first thing, we already kind of mentioned this, is that metals are going to tend to lose electrons. We're talking about metals like in group 1, group 2, most commonly. And when those lose their valence electrons, they form our positive ions. So when we form positive ions, what's going to happen to the size of the radii? Well, when they lose their valence electron, it now has one less shell. So in that example of, like, say, sodium 281, that's what it was as an atom. When I form a positive 1 ion, I'm now going to have the configuration 280. So instead of having 3 shells, it now only has the 2 shells. Okay, so due to less electron shells, the ionic radius is going to become smaller than the metal's atomic radius. So positive ions become smaller than their original atomic radius. And that's just there because, again, you have one less electron shell, so there's one less layer there. However, when you are forming negative ions, which are formed when nonmetals gain electrons, I like to think of the kind of what happens to the size of this, relating it back to if you've ever played Duck, Duck, Goose as a child. So when they gain one or more electrons, they're going to enter that same valence shell. So say I had chlorine, it would go from 287 to now 288. So that valence shell has one extra electron. Well, electrons are all negative. Okay, like charges repel. So electrons want to repel each other. So if you think about the little example of like a circle, okay, and you think about Duck, Duck, Goose. Okay, if those kids are sitting around in a tight circle, okay, shoulder to shoulder, and all of a sudden another kid wants to come into play, they all have to scoot back, okay, in order to fit someone else into the circle. So same thing here. In order for that electron to go into this third shell, those electrons are going to repel each other. They're going to need more space. So they move out, which causes them to move farther from the nucleus. So when nonmetals form their negative ions, okay, that additional electron repulsion is going to cause the ionic radius to become larger than the original nonmetal's atomic radius. So we have our nonmetal atom, it gains an electron. Those electrons are going to repel each other in the valence shell. So the nonmetal ion is going to become larger because of that electron-electron repulsion. All right, let's look at a few practice questions with the ions and ionic radius. So feel free to kind of pause this as you're going through these questions and I'll go over them. So when combining with non-metallic atoms, metallic atoms will. So we have non-metallic atoms and we have metallic atoms. So this is really talking about making an ionic bond. So metallic atoms, okay, metals are going to lose electrons. So I can throw out 2 and 4. And when they lose electrons and they've given away the negative charges, we're going to be left with a positive ion. Okay. Oops. Let me just erase that. Okay. So our best answer there is that metallic atoms are going to lose electrons and they will form positive ions when they do so. So you should get an answer of 1 there. So now a magnesium atom, so this would be our metal. is going to lose 2 electrons and become, well, losing electrons, again, is going to result in a positive ion. So I know I'm going to get rid of these first choices. And when it loses 2 electron, it's going to lose its valence shell. Okay, less PELs, less shells is going to result in a smaller radius. So your best choice here is going to be number 3. All right, going over to 3 and 4, when ionic bonds are formed, non-metallic atoms are going to do what? So non-metals are going to be the ones that are going to be gaining electrons. So I'm going to throw out 1 and 4 there. And when they gain those negative charges, they're going to form negative ions in the process. So we can get rid of any of the positive ion ones. So our best choice here is going to be that non-metallic atoms gain electrons and become negative ions. So number 3. And then an ion of which element has a larger radius than an atom of the same element? This is usually like a pretty hard question because you have to think through a couple of things. So if the ion is forming a larger radius, that means that it must have occurred by gaining electrons. Okay, and then from there, you would have to realize, well, in order to gain electrons and form this larger radius, I must then be looking for a nonmetal. And then using your periodic table, you would go through, identify each as metal or nonmetal. So remember your metals like aluminum, sodium, and magnesium are all to the left of the staircase. And then your nonmetal is going to be, chlorine, which is over on the right-hand side of the staircase. So this one will also be choice 3. All right, so you're going to go do some activities to practice this. Come back to this video or rewatch it if you need to.